and this is not going to be a comprehensive tutorial on threading. I am not qualified to give a comprehensive tutorial on threading.
Well, that was an understatement. Hello, and welcome to part 17 of how to code a game like Minecraft in Unity. In this part, we're going to be redoing part 12, because I it up. So I did mention in that video that I wasn't really qualified to be teaching anyone how to do threading, and I wasn't wrong. Basically, I had intended for this video to convert our threading system into the new Unity job system. However, after delving deeper into the Unity job system, I realized that the way we have our game set up at the minute, it would require basically starting over. We could make little bits of the game work with the Unity job system, but nothing major. Like to do the actual chunk generation and all that using the Unity job system, we'd have to rewrite everything. So I scrapped that idea and went back to fixing my original mistakes in the threading system itself. So the brief reason as to why things went wrong is we were essentially creating a new thread every time we wanted to generate a chunk. So in the chunk code itself, I'll pull it up. So in the chunk code itself, we have this here. So we're starting a new thread here when we generate a chunk. And then also down here, we're starting a new thread when we want to update the chunk. Now the problem with that is when you think that we've got dozens and dozens of chunks, we're starting a lot of threads, and evidently that causes problems with Unity. It starts to get a bit squiffy when there's more threads than there are cores. And obviously, like my machine, for example, only has 4 cores. The people who were reporting more problems with the threading system than I was experiencing, I imagine they have 2 cores. And maybe if somebody's running an 8-core machine, it wasn't quite as obvious to them. But basically, once you have more threads than there are cores, then you start to see problems with the threading, and that's basically what has happened with our code. So we're going to fix that. And the way we're going to fix that is we're going to do away with starting new threads, and we're just going to have a second consistent thread for updating chunks. First off, let's clean up our chunk thread, and the easiest way to find all our references is to just delete the using system threading, and that will throw up a few errors where we are using our chunk threads. So we'll get rid of that whole if statement and just have that populate voxel map. And then down here, so what we're going to do down here, well actually we're going to delete that whole function, and then we're just going to remake this one into public update chunk. So we just have the one update chunk function now, not a private one and a public one. We do not need thread locked because that's no longer going to come into play, and we don't need this lock around here. And then because we don't need that thread locked bool, we can remove it from up here, and that should throw up any errors for where we're using thread locked. So we're going to leave is editable as a bool because there will be some other stuff that we want to check in the future, even though for now it's just is voxel map populated. We could reference that bool directly, but we'll keep using is editable, and then if there are any other checks that we need, we can put them back in here. And finally, we want to change this, although we're going to be changing that again in a second. So before we go any further, there is one, while I was trying to get Unity jobs working, I did notice one error in the code. I mean, it wouldn't be one of my videos if I didn't kick off a new video by fixing an error from a previous video, which is ironic in this video because this whole video is fixing a whole other video. But anyway, if we pull up our world, I think it is, yeah, world script, we go down to check view distance. We have a slight mess up here in that our previously added chunks. So basically what we're doing here is we are copying our active chunks into our previously active chunks. Then we're going through, we're checking which chunks are active, and then we're comparing which chunks are currently active to the ones that were previously active, and any chunks that aren't in both lists, so that means they were previously active, now they are still active. Any chunks that aren't in both lists, that means that they are no longer active, and we deactivate them. The problem we've got here is that we never clear our active chunks list, so we're just constantly adding to it. So that's easy enough fixed by, once we've copied our active chunks list into our previously active chunks list, we just want to clear active chunks. And that problem would have bogged the game down over time as that list got bigger and bigger, because it meant that every time this check was run, it was essentially doubling in size, the list. So obviously that's going to make the game slower and slower. So sorry about that. I think I have mentioned I'm pretty much learning as I go, as well as you guys. So yeah, anytime you spot errors, don't assume that I probably know better. Like, feel free to point them out. If I do know better, or I feel like I know better, I will say so in the comments in a nice and polite way. But yeah, if you think you've spotted a mistake, there is a very good chance that it is a mistake. Don't be afraid to mention it, because it could be something that needs fixing. Right, so let's get our threading system fixed. If we just go back into our chunk, we're going to basically what we do, the way we're going to do it, in addition to having our separate consistent thread for updating chunks, we're also going to funnel everything through one method, because at the minute we have initialization here can be handled here, or it can be called separately because of this bool. So we can have the chunk automatically initialize itself when it starts, or we can have the chunk not initialize itself and then we can initialize it at a later date. And then there's other things like updating chunks can be called from in here. Where are we? Let's populate voxel map. Can be called from here, or it can be called from in here, and obviously it's all over the place. That is fine when we're not using threading, but when we're using threading it gets messy, and we need to be able to keep track of everything. So go into our chunk and we're going to get rid of this bool here, and obviously this here. We are no longer going to be initializing any chunk. There is only going to be one place where a chunk will be initialized from, and the same goes for is active. So get rid of is active, and then if we go into our world script, we should have a few errors that we can fix. So we just delete the bool reference there. And then we're going to delete this line here, and we're going to replace it with a chunks to create dot add. And you know what, actually we'll cache this. So as we're going to be using it twice. It's a small optimization, but better than nothing. So we're going to be adding it to the chunks to create. So basically the chunks to create function, or list, or whatever we called it, create chunks function, create chunk function, that is going to be in charge of any chunk initialization. So that is going to be the only place that chunks are initialized, and it's going to be the only place where chunks are added to the active, well, no, sorry, that's not going to be the only place where chunks are added to the active chunks list. That's going to be the only place where chunks are initialized, and check view distance is going to be the only place where chunks are added to the active chunk list. But before we get to modifying that, let's just get our threading system in place. So we need to add system.threading. And then we need to add a few objects up here, or a few references. So first off, we'll have our thread, which we're just going to call chunk update thread. Nice and simple. And then we need an object, which we're going to use to lock things. So the object will be public, and we're going to call it object. We'll just call it thread. We'll call it update thread lock. We'll call it chunk update thread lock. So basically, if you've forgotten how the lock statement works, if we put here lock chunk update thread lock and enclose that random line of code, there's no specific reason I picked that line of code, it's just closest to me right now. If we enclose that in this lock statement, and then we enclose some other code in the same lock statement using the same object, if one of those pieces of code starts running, the other piece will have to wait for it to finish, which is useful for when you're dealing with lists and threading, because when it's all on the same thread, you don't have to worry about it because everything runs sequentially, so something can't access the list at the same time as something else. But when you've got threading, two things could theoretically try and access the list at the same time, and that's why we're using the lock statement in this case. There are more performant ways of doing it, but they're, again, more complicated, and I'm hesitant to venture beyond my own realm of expertise right now. I do intend to learn all this stuff, so anything that I don't know right now, rest assured I am trying to figure out so that I can bring it to these videos. But for now, we're going to stick with the lock statement because it works. So in the start function, we need to get that thread going, and we're going to say chunk update thread equals new thread, new thread start, and then we need to give it a function. The function we're going to give it is called threaded update. We haven't got that function yet, so it's going to have an error. We're going to make that function next, and then just chunk update thread dot start. This is what we're going to do with this is kind of a no-no in threading. It's not a no-no in threading, it's a no-no for somebody as inexperienced as me. But I'm fairly confident that we've got our bases covered. If you're more experienced than me, please let me know in the comments. What we're going to do is, if we find a space, we'll go here below, just below update chunks. We're going to create, well, first of all, we're going to create our threaded update function. I think that's what I called it. Yep, threaded update. And in threaded update, we're going to say while, wait for it, dun dun dun, while true. And what this does is this will loop indefinitely until either the program ends or we stop this while loop. So that's generally considered a bad thing in threading. You don't want something going off in the distance, in the background and constantly running. So what we're going to do, just to make sure we don't leave anything going, it will say private void on disable, and then we're going to say chunk update thread dot abort. So whenever this script is disabled, be it because we've turned the world function off for some reason or because the game is being closed, the chunk thread will be aborted, so it's not going to carry on running in the background. So as long as the world thread is running, we want this thread running. This while loop kind of acts a bit like an update loop. It's not going to have the same time, like time.delta time or anything. It's not going to have the same frame interval, but it basically acts like a kind of secondary update loop, which is how we're going to use it. So if we go back to our proper update loop, we want to get rid, well, we want to copy actually. We want apply modifications. So we'll just copy that in there. And we want, what was it, update chunks. So if you remember with threading, any function called from a thread will be run on that same thread. So these functions are going to be run on the secondary thread. We can't call these functions, or we can't do this part on the secondary thread because this part deals with the Unity mesh, like the 3D mesh, and Unity is not thread safe. You can't run that on a secondary thread. It has to be on the main Unity thread. So we can't do this part on the secondary thread, and also we can't do this part on the secondary thread because that uses transforms and I think some material stuff. I can't remember exactly what goes on in the create chunk, but the main thing it uses is transform here, so we can't use that on the secondary thread either. But these two we can, because we tried to make them thread safe in the first place, and we're just going to clean up and make sure everything works now. So these ones are basically, it's going to constantly be looping in the background on the second thread, checking to see if there's any modifications to apply, checking to see if there's any chunks to update. Now we need to make chunks to update public because we're going to be accessing that from the chunk thread itself, and we want to go down to update chunks. I think there's a couple of changes to make here, and what we're going to do here is this whole line of code here needs to be put in the aforementioned lock statement. And the reason for that is because this is accessing the chunks to update list that we've just made public. The reason we've made it public is so that we can add to it directly from the chunk file, the chunk script. But because this list is being accessed on the secondary thread, we need to lock it when we're using it so that we don't have this bit of code. So this bit of code could theoretically get to here, check that the first item or the current index, whichever one it's looking at, is editable. Say, yes, it's editable. So we move on to the next bit, update chunk. But in between those two lines of code, the chunk could add another item. This code here could add another chunk to the list. And then this one, having checked that the item is editable, then begins updating a separate one, a different item, because something was added to it in the meantime. So by locking it, we ensure that, nothing can be added to it while this bit of code is running. And vice versa, this can't modify the list while something is being added to it, because we're going to put that in a lock as well. We'll do that now actually. So if we go into our chunk, we want the populate voxel map. No, we want edit voxel first. So edit voxel, I'm going to get rid of this update chunk, and we're going to get rid of this update chunk. And then instead what we're going to do is call our world dot chunks to update dot add. Does it take a chunk or a chunk card this? Yeah, it takes a chunk. Add this, and then down here, same again, world dot chunks to update dot add, and we're adding this. So basically we're adding it to the chunks to update thread rather than calling it directly. Now, first off, let's just put the lock statement in. So we're saying lock, and then we need to reference it because it's in the world dot chunk update thread lock. And because we're calling this function here from here, automatically this function is also locked because we're calling it from inside the lock. So we don't need to do it again here because this whole function is in the lock. Now, if you recall, the reason we had this directly updating rather than being added to the chunks to update list in the first place is because this is when the player modifies a chunk directly by breaking a block or placing a block or whatever, and we want that to be done as quickly as possible. It's okay for the chunks off in the distance that are being generated as you move through the world to take their time popping into existence, but when the player modifies a block, it needs to be updated, you know, as quickly as possible. So that's why we didn't add it to the list before, but now we are adding it to the list, so we need to just, you know, go about it a slightly different way. So we're not going to use add, we're going to use insert. And then what this can do is we can pass in an index. Our index is going to be 0, and this will put our chunk at the very top of the list. So it's still going to be waiting for the for this loop to get to it, but it's now going to be at the top of the list. And we're going to do the same thing down here. We're going to pass in 0 again because we want it to go at the top of the list. It doesn't matter really if for some reason it gets to this chunk before it gets to this chunk, because any block around the block that's being modified needs to be updated as quickly as possible. Like if this is against a neighboring chunk, if it doesn't get updated straight away, there's going to be like a hole in the world for a fraction of a second or something that you're going to be able to see through, and we don't want that. So it doesn't really matter which of these gets updated first because they all need to be updated as quickly as possible. So let's go back into our world thread, and basically we want to remove almost all references to active chunks dot add. That's actually the only one that we want to keep. So yeah, the check view distance is going to be the only place where we add chunks to the active chunks list. So I want to get rid of that one. Apply modifications. Yep, we want to get rid of that one. And is that all of them? Check view distance. Yeah, was the one in generate world? Oh, we already removed that one. Right, okay. So yeah, the only place that we're going to be accessing the active chunks list, adding to the active chunks list, is in generate view distance. So that avoids any confusion about what's in the list and what's not in the list. But then what we do need to do is at the end of our generate world, we want to call check view distance so that all the chunks that have been generated in the generate world function can be made visible. Because if you remember, we're no longer creating and activating them straight away, so we need to run check view distance because that's now in charge of all the creating, because that's now in charge of all the activating of chunks. So we need to run that after we've done our generate world script to turn all these chunks on. We already removed is active equals true from our chunk constructor, did we not? I'm forgetting things that happened 15 minutes ago. Yes. Yeah. So our chunk is no longer setting itself to active. That should be dealt with in the check view distance. Check view distance. So the only place that a chunk is set to active now is in the check view distance. And if we go down here, so the only place a chunk can be set to active or not active is in the check view distance. So we're kind of like funneling down everything so that a single function is responsible for a particular behavior and it doesn't happen anywhere else. If we want to initialize a chunk, we add it to the chunks to create function. If we want a chunk to be active, we have to be within the view distance, and the view distance will take care of it. We're not doing things outside of that, and then that way there's no confusion about what's happening where. Don't need this lock anymore. Put the proper brackets around that. I tell a lie, actually, there is one other place we need to add to our active chunks list, and that is in the update chunks function. So we just do active chunks dot add, and then we'll just copy this chunks.card. Also at the top here, not at the top, sorry, in generate, no, at the top. We actually want to start our thread before we call our generate world function, because that thread needs to be running as soon as we want the thread to be running before we start trying to generate chunks. I mean, the chunks will wait for the thread. It's not like they're gonna, try and generate and then disappear into the ether when they can't, but, we want it to get going as soon as it can. I've got a feeling I've missed something, but let's just run it and watch the carnage. Yeah, something's not right here. Yeah, it's running slower than when it's than without threading. The fact that this enable threading bull here isn't enabled doesn't affect it because we haven't re-entered a check for that. So at the minute, threading is just enabled by default. We will re-add that check. But yeah, this definitely isn't right. Yeah, and we're getting some chunks not generating at all. Right, so, and we have an error. Right, I'm just going to quickly figure out what I've done wrong here, and I will be back shortly.
A few moments later.
Oh, there is, right, okay. Yeah, we shouldn't have this. Sorry. I believe I did say that we were going to change that at some point in the video. Yeah, we don't want to be calling our update chunk function directly. We want to be adding it to world.chunks to update. And we don't need to insert it this time because this is just initialization, so we're assuming that this chunk is just being generated. It doesn't need to be given priority, but we do need to lock it. World.chunk update thread lock. And also we missed a chunks to update add here. And this one's the worst one because this one actually checks to see if the chunk is already in the list before it adds it to it. So we'll get rid of that. And then in here, we want to put chunks to create dot add. So basically, we're not adding it to the chunks to update list anymore. We're just adding it to the chunks to create list. And then the chunk update function, the chunk create function will handle everything else. I think that might be all the mistakes. Maybe. Well, that looks a lot cleaner. Do a little test run. Don't worry about the random pattern of the chunks generating. That's just because of the voxel mods, voxel modifications altering nearby chunks. And these random light artifacts here, I mentioned that in the last video, that's the chunk to chunk lighting. And we'll fix as soon as maybe in the next video, I'm not sure. We will fix that. Well, definitely in the next Minecraft video. I'm just not sure if the next video is going to be a Minecraft video. But the next Minecraft video, we will finish off the lighting. It's just we needed to fix this chunk, this threading issue before we could move on to the chunk to chunk stuff. But the important thing is that our chunks are generating and unloading as we move around, which is what we wanted. And obviously you can mess around with your world size and your view distance, and it's just a lot smoother than it was without it. So, okay, that's that. Let's just quickly re-enable or re-add in our enable threading check. So, where are we? At the top, where we start our new thread, we'll enclose this in an if statement. So, if enable threading. So we only start this new thread if we're enabling threading. We'll just copy that. And then likewise, we're only going to disable the thread if we're on enable threading. One thing you will have to do is make sure that enable threading is not changed during the game. So what we're going to have to do when we get around to proper options and stuff is ensure that enable threading can't be changed at runtime, or at least during the game's runtime, because if we have threading enabled at the start, we're going to start the thread, but then when we end the game, if enable threading gets turned off during the game, then we're not going to abort the thread. Basically, whatever enable threading is at the start is going to have to stay that way. But for now, we're just going to leave it because I'm running a bit short on time. Don't worry, the unit, while you're running things in the editor, Unity's editor will cancel any threads that are running, so you don't have to worry about it when you're testing it. It is something that would need to be fixed before you did a build, though. And then the last thing we're going to do to properly do that. Obviously, this threaded update is running this indefinite while loop, so we can't just call that from the update thread, because then this function would just run indefinitely and completely freeze up the main thread. So if we go to our update, we'll put, well, we don't want the while loop. That was the whole point of copying the code. We'll put that there, and then we will copy our if threading enabled if statement, slap that there, and then we want to make it if not enabled. So this bit of code is only going to run if threading is not enabled. And then what that means is that if threading is enabled, it sets the second thread running, which runs this indefinite loop. And if it's not enabled, every update loop, it'll do this, which will obviously be on the main thread and everything will be much slower, but it's, I guess there may be some situations where you want to turn threading off. As far as I know with Unity, if you try and use threading and the machine that you're using isn't capable of it, then it will just work like as though we'd turn threading off with this bull here. So Unity would kind of handle it itself, but I understand that you may want to be able to do it yourself as well, or maybe you want to turn threading off to compare speeds. But that, I think, is okay. So this should run slow now because I haven't got threading turned on. Yeah, that's quite laggy. So let's just turn threading on. Much snappier. And if we go for a bit of a wander, we should see less of a lag spike when we actually get chunks. Oh, no lag spike when we get chunks generated. So that is it for now. Like I say, in the next Minecraft video, we'll finish off the lighting system and deal with these weird chunk-to-chunk lighting issues, which seem to be worse in this video than I remember them being in the last video, but it's either way, we needed to fix it regardless. And also I don't remember turning the lighting down, but these shadows don't look very dark. But yeah, we'll finish that off in the next Minecraft video. I'm not sure if the next video will be a Minecraft video, but yeah, other than that, like I say, next video, lighting video, finish that off, and then I guess, as always, in the comments, let me know what you would like me to cover next. Just remember that baby steps, we can't go on to a full survival mode system before we've got a functional game to play it in. So one of the requests that I keep seeing quite regularly now is things like caves and a bit more world feature, a bit more to look at than just trees and grass. So that's one that I'm quite interested in having a go at. So if you'd like that, let me know. Or if it's something else, let me know. Sounds is another one, footsteps and whatnot, and breaking block sounds. So that could be another one. But for now, that's it, and I will see you next time. Bye-bye.